mass 2.5 kilograms, then it weighs 0.5. Thirty centimeters. Determine the maximum and minimum pressure. When it is empty. Namobelo Latifa, can you mute? Mute, Bushira mute. Now class, with this number, what did you do? They told us to find the maximum pressure and minimum when the box was empty. When this tin was empty. What steps did you go through to get the answer? What were the steps? Who can tell us the steps? You raise up your hand, then I select. What are the steps of getting the maximum pressure? First of all, what is the formula for maximum pressure? Who can tell us the formula for getting maximum pressure? Yes, Hujurat. Now wait a minute, I see your hand up. Samantha? Sima Nancy, what's your formula for maximum pressure? Now Kenya, when I call your name, you unmute and tell us the answer. I see your Cinderella. Putting up their hands. Are you putting up your hands that you got the answers, or you are putting up your, because when I call somebody's name, you are not replying. Chigozi Nusrat, what is the formula for maximum pressure? Natalie. Who can tell us the formula for maximum pressure? Yes, Tefe, your hand is up. Wait, are you able to hear what I'm asking for? Can you hear what I'm asking for, class? Now wait a minute. Now wait a minute. Can you unmute and talk to me? Okay, who can say hi? Can somebody say hi from class? Any person to say hi? I don't know who is this one sharing the screen. Nankabira, don't share screen. Nankabira, please do not share the screen. Okay, maximum pressure is equal to force out of area. Force out of minimum area. So in this number, when the box is empty, what is the force? How shall we get the force when the box is empty? When the box is empty, how do we get the force? Now wait a minute, can you remove your screenshot that you are sharing? There is a lot of confusion in your class. Please, now wait a minute, don't share screen. Okay, how do you get the force? Samantha, how do you get the force when the box is empty? I don't share screen. This is a very disorganized class today.
Bibi, Danica. Danica. Quanche io a cagno con la
Samantha,
Yes.
how do you get the force?
Teacher, you had
Admitted
us.
Teacher, you had admitted all of us.
Yes, that's why we weren't speaking.
Actually, we are telling
Yeah.
I don't mute us. So now
You were asking
So you muted
questions
us
when
and
we were
even
already
disabled the chat room.
muted.
And some people are
Yeah.
even putting their messages on the
That's why
what?
people
On
were
the
sharing
group.
their screens. They were trying to tell you that you had muted us.
now I have allowed the chat. I have allowed.
Okay.
I have allowed.
Organized class.
Okay. Don't have anything to comment. Please, you don't put up your hand. Okay, now wait a minute. How do you get the force?
Teacher, force
There is
is
force.
equal to I mean,
Force is equal to what?
like the
mg.
SI unit of force is Newton.
Force. Okay. The mass, when the tin is empty, they told us when the, first of all, Roman 1, the first part was when the tin is empty. If it is empty, mass is 2.5. So we shall have 2.5 times 10.
I can't hear you.
Guys, please stop pinning yourselves.
Oh,
I'm a teacher muted.
Yes.
Can you mute us?
Guys, please stop pinning yourselves.
These are the areas we are getting. The first area, we have multiplied with this times this. Then, what answers do we get here? In area 2, we can get with this times height.
Teacher, we can't see.
Are you following? Do you know what I'm doing?
No,
Do
No,
you know what
teacher.
I'm doing?
we don't understand.
We are getting all the 3 areas. We want first get all the 3 areas. After getting the 3 areas, we shall pick out which one is minimum and which one is maximum. And people have not unmuted. If you're not speaking, you mute. Namaya, Jay first. Eh? Okay, now what I was saying, remember these formulas of pressure, of maximum and minimum. For these formulas, at some stage, you need a minimum area, and at some other stage, we need maximum area. Now, the areas I got from the box itself. This one here. So what I'm trying to do, I'm first getting all the 3 areas, and area 3 is width times height. Now, out of these 3, we shall pick out which one is minimum and which one is maximum. That's what I'm trying to do here. So when I do this, because I don't know whether area 1 is minimum or it is area 2 or area 3. So let us first get all the 3 areas. The first one is this, length times width. That's why I was putting 30, but 30 is centimeters. 30 is centimeters. How do you convert centimeters to meters? So we need to convert SI units. How do you convert meters to meters? How do you convert centimeters to meters?
1 centimeter is like 100 centimeters.
So we divide by what figure? I don't know what's happening. Is there a person who can see me?
No, we can't. Yes, teacher, I can see you, but
Yes, teacher.
background
The network is poor.
is low.
Teacher, we can see you.
We can see you, but
Drama
not very
teacher, we can
clearly
see.
like before.
We can see properly.
We
Teacher,
can't.
for those who can't see, please check your network.
Me, I can see
Check
you.
your network.
Very clear.
Okay, 30. What I'm asking, I want to get this 30 centimeters to meters. So I divide 30 by 100 because we want to convert to meters, but the width number has 20 millimeters. How do you convert millimeters to meters? How do you convert millimeters to meters? Millimeters to meters. What do you divide with?
Divide by 1,000.
By 1,000. So here we divide by 1,000. Now what we are trying to do, we are getting this first area and we want this area to be in SI units. We want it to be in meters. That's why each figure that you put here must be converted. You must convert that figure to meters. Now for those of you who have seen this, what will be the answer here? What will be the answer here?
0.006 square meters.
0.006. Is everybody getting that figure?
Yes, teacher.
Yes.
But this is the first area. Remember, our target is to cross-check out of the 3 areas, which one is minimum. So let us go to this. Let us also work out length and width. Let us 30 out of 30 out of. Now, what am I going to divide with the 0.5? If you're not speaking, you mute. If you're not speaking, you mute. What are we going to divide here? Do we divide with anything here?
No.
For 0.5, what are we dividing with? So 0.5, what shall we divide with?
Nothing.
Yes,
Wait,
we
what
don't divide by
about
anything.
5 out of 10?
Wait, we are changing,
Nothing.
we are changing to meters. But already in the diagram, 0.5 is in meters. It's already meters, so we don't divide by anything here. So what's the answer for this?
0.1.
1.5. Now that is the second area. Somebody who has not understood, we are just dividing, we are just getting areas. We are first checking all the three areas, then we shall pick out which one is the minimum and which one is the maximum. Because before you find those areas, you don't know which one is minimum and which one is maximum. So what we are going to do is to first cross-check the three areas before we put in our final formula for pressure, because the final formula for pressure has minimum area in it. And now we are converting each unit, each item, each figure. In physics, you must put all the figures in SI units. And the box, if you look at the tin that we gave, the tin had different units. Here it had centimeters. Here it had millimeters. Here it has meters. So as I multiply here, I try to look at how do I convert each to its SI unit. Let us check area number 3. Area 3 is 20, but the 20 is in millimeters. So we need to convert millimeters to meters. Like what we did here, we shall divide by 1,000. So multiply by the height, which is 0.5. What do we get?
0.01.
And I'm putting the units meters squared. I'm putting the units meters squared. Now, who can explain to us why are we getting these three areas? What is the purpose of getting the three areas? Who can tell us why do we need to get A1, A2, A3? Why? Why do we get them?
So that we can
The minimum area.
Yes, so that we can compare and see which of the three is the minimum and which of the three is the maximum. Because in a working, we need maximum and minimum areas. So, who can now tell us, out of these ones, which one is minimum? Out of these three answers, which one is the smallest?
0.01.
0.006.
This one is the smallest. So, this is the minimum. Which one is the largest? Out of the three, which one is the largest?
0.15. 0.15.
So this is the maximum.
Just listen to the calculation. Now what you are
So now, out of the three, we have identified the minimum and the maximum. Now we are comfortably going to put in our formula. Now we go to the question itself. The question was asking for maximum pressure and minimum pressure. So in this formula, but they told us you first work out when the box is empty. So force is this. This is the force. We shall put 25. Now in the denominator, what am I going to write here in the denominator? What am I writing in the denominator?
0.006.
0.006.
0.000. And what answer do you get? What answer do you get?
4,166.667.
400.
4,166.7.
What are the units? Pascals or newtons per meter squared. Is the class following what we are doing?
Yes.
Yes, teacher.
Remember, in the question, there was Roman 1, Roman 2, and Roman 3. And in each Roman, we have to get the maximum and the minimum pressure. Now, at the moment, we are dealing with the box empty. When there was nothing in that box, empty box. The empty box, we have got maximum pressure. How do we get minimum pressure when the box is empty?
Whenever I start understanding these things, I come in the middle of the lesson.
How do we get minimum pressure? When the box is empty, what formula are we going to use?
Minimum pressure equals to force out of maximum area.
Can you come with the
Minimum pressure
there are only two numbers. Yes.
is equal to force out of maximum.
Let me first.
So what are we substituting?
25
What are we,
out of
what are we
0.15.
0.15, very good. What answer do we get? What answer shall we get here?
$166.7 Pascal.
The Pascals, I sometimes use this.
Some of us stop pinning yourself, Sarah, Nachibala, stop.
Even class.
Why are you breaking? First, we can't see. At a point, we see. At a point, I don't.
Send you pin teacher on your screen.
People who are pinning their screens, stop pinning your screens. Okay, that is the work that we have. I have told you Roman 1 is empty box, and we have got its minimum and maximum when the box is empty. I want to see any questions so far of what we are doing. We can summarize what we have said. We have said you first get all the 3 areas. Out of those 3 areas, pick out which one is maximum and which one is minimum. Then, according to the formula, you substitute in what you want. If you're looking for maximum pressure, it will require minimum area. Of your 3, pick the minimum area and put it here. And somebody should be able to remember how we got 25. This 25 was the force. But in the question, they gave us mass. They didn't give us force. They gave us mass. So what we did, we said force is equal to mg. Force is the same as weight. M times G. So you get your mass, kilograms, and multiply it with the G. Our G is standard, it is 10. That's how we got 25. So this 25 is what we substituted for force. Force is 25 out of 0.06. And that's how we got our maximum pressure. You can even check. You can check the 2 answers. The answer for maximum pressure and the one for minimum pressure. Do you think they agree with the statements maximum and minimum?
I'll never know which one is maximum.
It's true. It's true, one is bigger than the other. The maximum bigger than the minimum. Maximum pressure is.
Teacher, I can't.
Which one can't you see?
Can't see the blackboard.
I don't know what is it. Network.
Yes, teacher, some of us can't see. Oh, Hannah, we can see.
You can now see it.
Now we
Someone
can't see.
else's screen goes on.
Yes, super over
Now
pinning
again we
finish.
can't see.
You guys
I'm in
were
the shadow.
over talking. That's why we can't see our teacher.
We are seeing other people's screen.
Talking. That's why we can't see.
You've been teaching
Okay,
them
you mute.
Everyone.
Okay, let people first mute. Let everyone first mute.
Yeah, at
Let
least.
everyone first mute. Can we first mute?
Hey, people were like,
Are we now able to see the board?
no.
Yeah. Yes.
Yes, teacher,
Yes,
we can see
yes,
that
we
board.
can.
What
We
else?
can see the
Science,
board.
you should go and check
We
if
can't
they
see the
admit
board.
her.
We
Can't
can't.
teacher continue.
Okay, okay.
We can't see the board.
Stop
those,
We can
pinning.
see other people's screen.
those who are not
I
seeing
can
the screen,
see him, but in like a small square.
Just more then after we shall see.
No, we
It's your
can't.
data. Bana mutuveko.
who has
You
can see him in a small square.
everyone.
That
Sha.
means it's your network.
You'll be like, hey
Most
guys,
people
I've been
can see you, teacher, including me.
everyone. Some of us.
We can see from the other side.
At a point we don't see. Katika tuna
We can't see.
Like Chilas.
Guys,
Adza, can you see teacher?
Just
okay, you mute. Can you mute your audience?
we
People
can't
mute.
see. We can't
Okay,
see.
okay. I'll take that recorded. Namara, can you mute? Bushra mute. Wilder mute. I'll share the recorded video. You will see the recorded video. Because now I can't do anything for those who can't see me.
You don't force.
Now, part 2. What was part 2 of the question? Let me show you part 2 of the question. Part 2 of the question has what would be the minimum and maximum pressure when the tank is filled with water up to the brim. What does it mean when they say up to the brim?
All this is catastrophe. Filled with fullest.
I didn't even see that diagram.
What do they mean when they say up to the brim?
They want us to use the maximum area.
Yes, we are still going to do maximum and minimum pressure, but now they are saying the box is not empty. The box is filled with water up to the brim. So what does that one change in our working? Does it change the minimum areas or maximum areas? Do those figures change? When I pour in water, does the maximum area or minimum area change?
No.
Yeah, the areas do not change because by pouring water, you don't change the size of the box. It is the same size. But what do you think is going to change in our working? When I put in water, what will change? The mass. Very good. That is so nice. The mass is going to change. Remember, when the box was empty,
The area does not change.
yeah, the area doesn't change because you have not changed the size of the box. The tank is the same tank. Now, how is the mass going to change? Because the empty tank is 2.5 kilograms. So how will that mass change? When you fill in water up to the brim, that is full tank. How will the mass change? So now we need total mass. Total mass is equal to mass of the tank.
Plus mass of the water.
Yes, plus mass of the water. Yes, very good. So how shall we get mass of the water? Have they given us the mass of the water?
No.
No, they've given us density.
When they give you density, how do you find mass? When they give you density of water is 1,000. So how shall we get that? Total mass Total mass.
No.
Total mass. This is Roman 2.
You're supposed to spend almost 7.
Mm.
So this is 2.5. How do we get the mass of water? Who can tell us how do we get the mass of water?
Density
Teacher,
times volume.
we say density is equals to mass out of volume. Then we say 1000 equals to mass.
Out of volume. Its mass. So mass will be density. Is it density times volume?
Yes.
Okay. Mass of water, density.
Anyway, I look for people I actually
The
talk
density
to.
is 1. What is the volume? What is the volume of water for this case?
0.003 meters
How
cubed.
did you get the volume?
Is width times height.
Length times width times height. What was the length?
0.3 meters.
Who is that?
0.3. What was the width? What was the width?
0.02 meters.
0.02 because it was millimeters. Then the height?
0.5 meters.
0.5. Very good. Are people following? Are the students following what we are doing?
Yes.
Yes, teacher.
What we are getting the mass of water. Alone, when we get the mass of this water, we shall add that answer to the mass of the tank such that we know the total mass. Total mass. When you multiply, what do you get here? When you multiply, when you multiply, what do you get?
3 kilograms.
Compound, you can hit me for now. I was out from class, that's when you wanted to cane us with a broom. One time was this behind another physical
0.00.
0.0.
0.003.
How many zeros?
2 and 3.
This is what units? What units are for this? What are the units for this? Units. What are the units for this? This answer that
Teacher,
we are
you
getting
still have to
Nothing.
multiply by 1,000.
It means multiplied by 1,000.
Teacher, mine.
Multiply by 1,000.
After multiplying
Can't see. I'm seeing.
Teacher, you have to multiply by 1,000.
You get
1,000. So the answer is 3.
3 kilograms.
Answer is 3.
yes.
3 kilograms.
Okay. Okay, now, so with that case, what is now the total mass? So what is the total mass? Remember, we are looking for the total mass. So what is now the total mass? This part. So total mass.
5.5 kilograms.
Total mass
2.5 kilograms per.
So now in this case, the mass that we are going to use is 5.5 because you're looking for the part when the water was filling up the tin. So we get the mass of the tin itself plus the mass of the water. It's what we're getting. And the use of this mass, don't forget, why do we get the mass? We get the mass to help us get the force. And why do we get the force? It is because in the formula for pressure, there is force. Am I making myself clear?
Yes,
You
teacher.
should know why do you get a certain item. We are getting mass to help us get force. And we are getting force to help us get pressure. So when you substitute in 5.5 times 10. But don't forget, this is not the final answer. The question was asking for maximum and minimum pressure. So for maximum pressure,
Can't see.
is equal to force out of minimum. So now what are we going to write? Force out of minimum area. So what am I putting for force?
55 Newton.
Minimum area. What is the minimum area?
0.006.
Because we said for the areas they didn't change. That's what we said. So what's the final answer here? What is the answer?
It's
9,166.7. 667.
So that is how we are supposed to get maximum pressure. Now get minimum pressure. Remember, in each part you have to get the two pressures, the minimum and maximum. In each part that you reach. So part one is max. So what about minimum? Minimum pressure.
Out of maximum area.
Yes, force out of maximum area. Does the force change or we still use 55? We still use 55 or we get another figure?
It's still the same.
So what is the maximum area? What was our maximum area?
0.15.
So finally, what you get as your answer?
366.7.
Somebody mute. Tell your brother to mute for you.
Most people are not muted and they're not saying anything.
Answers we are expected to get in Roman 2. Those are the answers.
So we are not
expected to get.
seeing.
And you'll get a recorded lesson. If you're not saying, you get a
Just
recorded
see, teacher. Just double tap his whatever.
Huh?
So we can't see.
Double tap his small video.
Double tap the picture. Yeah, it's on the other side.
Can you now see it?
Yes, teacher.
No.
So we still can't see.
Hello?
Teacher, we can't
Hello?
see.
Hi.
You can't see it.
I can't see. I can't see.
You can't see the screen.
Now I can't see.
Now you can see it. Eh?
Yes.
Yes.
No, see my network as okay. I want, is there any person who is asking on what we are doing? Can somebody ask which part you have not understood? Or why you can say, why are we getting this and this? In that we explain it properly. Or I assume you have understood what we are doing. To summarize what we are doing. To summarize what we are doing, because there is part 3 that I'm going to allow you to do yourself. To summarize what we are doing, the question was asking us, it gave us a diagram. The question gave us that diagram. And when they gave us that diagram, they told us to determine the maximum and the minimum pressure exerted when the tank is empty, when the tank is filled with water up to the brim, and when the tank is filled with halfway with water. So what we are just doing right now, we are getting the 3 sections. First got when the tank was empty. Now we have gotten when the tank has mass in it. So when the tank has water in it, total mass, in that new case, the total mass is the mass of the tank plus the mass of the water. Unfortunately, we don't have the mass of water. So before we go into adding, we have first found the mass of water. This part here is mass of water. But we know that the formula for mass is density times volume. And the density of water is 1,000. That we use in calculations. The volume, now volume is the volume of that tank. Volume of that tank. It had a length, width, and height. Now these figures you see here are figures after converting them to meters, because this one was centimeters, 30 centimeters. When you convert to meters, you get 0.3. This one was 20 millimeters. When you converted 20 millimeters to meters, this is what you have. This one was meters. If it is in meters, don't change it. You leave it the way it is in meters. So when you multiply all these figures here, you end up getting 3 kilograms. Now, these 3 kilograms represent the mass of water. But what we want, we don't want only the mass of water. For us, we want the total mass. The total mass means the mass of the tank plus the mass of the water. That's why we did 2.5 plus 3. And we got 5.5. And again, we said, in the formula for pressure, there is force over area. But what is the force? So you go and use this mass to help you get the force. How do you use the mass? Multiply mass times the G. The acceleration due to gravity, which is always 10. So 5.5 times 10, you get 55. Now, after getting force, now you come to the formula. Maximum pressure is force out of minimum area. Force is 55. The minimum, we got these areas in the beginning, if you remember. In the beginning, so how this and this, you come to this. When you go to minimum pressure, force out of maximum area, so you substitute like that. That's how we have gotten these answers. I hope now that is clear. There is part 3, when the tank was halfway filled. When the tank was halfway filled with water. People who are talking to Bella, I don't know who is Bella. Can you pay attention? Attention to the chats and you're not paying attention to the teacher. I'll block the chats. People who are
Teacher,
asking,
block
Bella, Sister Swat, can you leave the whoever is Bella?
block them. Block.
181.
Can we now go to Roman 3? Roman 3 of this number was when the tank is halfway filled. I want somebody to tell us what is going to change in that part. What do you think will change in Roman 3?
The volume.
The volume will change.
The volume. We get halfway the volume. That will be 0.25.
So our volume was this. So we shall divide that volume by 2. Now, can you continue to get for me that answer?
0.25.
Now, continue to get for me the answer. It means this will be for that working, we are only going to have to divide by 2. The volume, because it's halfway through. What will be your final answer now? What is the final answer? We are looking for tank what is half filled, half. And we said this word of half on 2. So our volume is this, we are dividing it by 2. Those with calculators, what is your final? This is the volume, but now what half of it? Half of the volume is divided by 2. People with calculators, divide it by 2, what do you get?
0.0015.
Multiply by 1,000. Oh, by the way, let me ask you something. As the density, are we also going to divide density by 2? Shall we divide density by 2?
No.
No.
Don't divide it by
No.
2.
No.
So 1.5 kilograms. 1.5 kilograms. Are we together on what we are doing? My babies of senior 2.
Yes, teacher.
Yes, teacher.
Do you know why we have divided by 2? Do you know why we are dividing by 2?
Because the density is half filled. The volume is
Yes.
We are finding the total mass of half of the tank.
Because in this number, in Roman 3, we have this half filled. Roman 3 has half filled. So the tank is halfway. Halfway means the water that will be there will be half. So when you get the total volume, divide it by 2. But in the other part 2, in part 2, they told us it was filled to the brim. It was full filled. The water was filling up the entire tank. So in part 2, we didn't divide by 2. We got the entire volume. But in part 3, we are dividing by 2 because it is halfway filled. And now when you get this 1.5, what are we going to do to this 1.5? Where do you take the 1.5? The one we have got. Where do you take it?
We change it to newtons.
No, teacher. I have a question. Teacher, I also have a question. Teacher, wouldn't we just do 3 divide by?
Yes.
Teacher, please disable the chat.
Because you're asking?
Teacher, you have said we divide the volume by 2. But to me, what I think we only divide the height by 2.
Auntie, when divide by 2 the height, it will come to this. It's like dividing the volume by 2. It's the same thing.
Okay.
It is halfway. Higher. And now wait a minute, you're asking, I see your hand is up.
Teacher, I was asking on the other part of 3.66.7, like 3.667, eh? Yes, can you just write 366.6?
That you have to round off because there are many sixes here. It is 366.66. There are so many sixes. So if you don't not write all the other sixes, then you round off. Just write this one, but you make it simple. There is rounding off. That's what you have done. Any other question? And Amina Stasha. Amina, you have a question? I see your hand is up.
Yes, I have a question. Now,
you
teacher,
ask.
can we just do 3 divided by 2? Like that.
Hey, you can do that.
Which was that?
Yeah, that one is also okay. You divide the mass divided by 2. When they are marking, of course, you might miss some bonus marks somewhere of not showing how you got that 2, but it's also okay. It can give you the 1.5. Though in exams, you show all the working. You can first get the mass, divide it by 2 if you want. Or you can get the volume, divided by 2, because it comes to the same answer. Lukwago, you have a question?
Yes, teacher.
I see your hand is up. Yes? Yes, Lukwago, ask.
Asking.
You wanted to? You wanted to ask?
Same mass of tank plus mass of water out of 2.
Hey, actually, don't divide the mass of, okay. When you add 0.5 plus 1.5, what do you get here? Here you get 4. Is asking a very nice question. What we do, we don't divide, we don't first add, because in the other previous number, it was 2.5 plus 3, and it was 5.5. When you divide this by 2, when you divide this by 2, what do you get? Here I'll get something like 2.75. You see, this 2.75 is not the same as 4. Look, are you following what I'm saying?
Yes.
Yeah, we don't divide. Why don't we divide by 2? Because the 2.5, for it remains 2.5. Because the tank doesn't reduce to half. It is only the water that you are putting there that divides by 2, the water. So the tank remains as 2.5. So you only do the divisions on the water, on the mass of water or the volume of water. Are you together, Rupago?
Yes.
Okay, now we go. This is mg. So we say 4 times 10. We end up with 40. Newton Z. After the mass, again we continue and get our answer. The working was very simple, only that you have to first understand this part, because these are just substituting in. But in each part, you have to get the maximum and minimum in each part. So for those ones who have understood, these ones are going to change now. These answers will change. So here we shall have 40. Our area minimum was 0.006. Here we are going to get again 40, and our maximum was 0.15. I want you now to appreciate the reason why. You first get the areas at once, so that every time you want to use one of those areas, you just pick it from there. You just pick your maximum and you pick your minimum according to what you want to use. I want the answers now.
The maximum is 6,666.7.
And minimum?
And the minimum is 266.7 Pascal.
7.
Okay, Pascals, it's okay. It's okay to use Pascals just because I normally use this. Okay. That marks the end of that number. That's how you have to do that number. You see, when I give you questions and you don't try them, that's the challenge. When it comes to class, you feel like you understand. So please, when I give you questions, always try. Now, there are those other questions which were there. Those ones have to do them. I will not do them for you. Those ones you do and send me my inbox. I wanted us to see some of the applications of this pressure, this thing of minimum and maximum. Those who are copying solution, copy very fast, then we talk about applications.
Excuse me, teacher.
How many of you have? Yes, somebody is asking. You are excused.
When we are working out tank, when the tank is half filled, why is the density 1000?
Anti-density of water doesn't change. The density, because you're looking for mass, we don't know the mass. Mass is density times volume. Yeah? But now that density is anyways 1000, density does not change. So we have to put 1000 because you are getting mass. To get mass, density times volume. You get why we are multiplying. Nai Gaga, have you understood why we multiplied by 1000?
Yes.
What are you getting from there? What's what?
What's about?
I don't leave him.
Nankabira, I see your hand is up. The rest you mute. I'm on a mute. Yes, Nankabira.
Can you explain the last
Naila?
explanation, minimum pressure that you did on this tank that was half filled? The last talking. Can you please explain?
People, can you mute? Okay, now come you are asking. We are asking how, did you get to know how we got 40? Do you know how we got 40?
Yes, teacher. Yes. Yes, I know.
Now, Kamera, what is your question? Because you know how we got these two. We just divided.
The maximum area.
The rest mute.
Even maximum area, the same force is used. This same force you have got here. So the same force divided by the minimum, and once we got earlier, we divide this by this, you get out with this. Now, Kamera, you see what we are saying? We are just dividing. Asio mute. Cinderella mute. So where D mute. Nansambu Shakira mute. Darlene mute. Naila Nasasa Shukra mute. I'm on a mute.
The printer also hurry. Guys, please mute.
Shivan.
Just mute us.
Not people will not be able to ask if I mute everyone. People
They will raise up their hands.
People, okay, there's Stacy, your hand is up. Do you have a question? There is also Elizabeth. Okay, Stacy, ask your question.
Up there on the force out of minimum area there.
Me, I've got like 1,666.7 and you wrote only 666.7.
People at me, the 6,000.
Yes.
Okay, sorry, I think I missed up the first six. Yeah, thank you for that correction. Elizabeth.
Teacher, I was asking like on how like on the part we have filled with water, like we got our mass as 1.5, but then why did you add the total mass to the 1.5 that we got?
Auntie, we are getting the entire pressure exerted by the tank when it has water in it. Even the tank is having weight. So the tank plus the water, the total, because we can't say that the maximum pressure is only from the water, from the mass of water, because the water is in a tank. Even the tank has a mass. That's why in the two cases, we have gotten the total mass, meaning that the tank and the water, they all exert their mass on the ground. Is it okay?
Thank you, teacher. Yes.
Then, Nabu Kenya, your hand is up.
So, teacher, is the force the weight of the tank when there is water in it?
Yes, that word force represents weight.
Okay.
Then who else is asking? Shukra, can you mute yourself? Shukra, Yolanda, Shukra, Billy, Dave, mute. Okay, now I want to ask you a question. The knife that you use at home to cut, to peel matoke, the knives, which part do you use? Do you use the sharp side or the other blunt side?
The sharp side.
The sharp side.
The sharp side.
Why don't you use the blunt side?
Because the blunt side exerts less pressure while the sharp side exerts more pressure.
Because the sharp this side, this is the sharp side. The blunt side. In terms of area, let us look at in terms of area. Okay? In terms of area, which one has a smaller area? Which of the two has a smaller?
The sharp side.
The sharp side.
Smaller area. And it has a larger area. Now, they will ask you why is it? They will ask you why it is easy to use the sharp side. But you know pressure.
It exerts less.
So this is pressure is force out of area. Which of the two sides? Which of the two sides exerts more pressure? The one for small area or the one for large area?
The one for large area.
The one for small area.
The one for small area exerts more pressure with the same force. So that's sharp. Okay, we can say, I'm trying to answer for you the question why this one is smaller. Since pressure, you write this one down. Since pressure is inversely proportional. Since this is how we should answer such numbers in physics. Since pressure is inversely proportional to area,
Stop making those beast sounds.
Weird.
You're not even funny.
Sing for us.
Who's singing? I gotta spend it all. I'll give you a lot. I'll get you ping ping. If you show me your love, ping ping.
CRISPR mute.
Okay, the question.
It's CRISPR.
Yes. Yeah, I'm not.
That's how we answer some of those questions. They'll ask you why is it easy to cut using the sharp end. That's how to do. You don't just write because it has a small area. No, in physics, you write the real science. You do the explanation. When they give it like 2 marks, you must have written the explanation well. In that they are able to do what? We have said, you Amone, leave the Bella girl alone.
Okay.
Andika question.
Ella don't think like
Andika which? Answer which?
Is watching.
This question is what?
How many of you have high-heeled shoes?
Me.
All right.
If you have to move like through mud, is it very easy for you to use your kakondo to move through mud?
No.
What will be the problem if somebody has flat shoes compared to high-heeled shoes?
Flat shoes.
Teacher, blocking.
Okay, you're blocking. We haven't finished writing.
Hey, so I'm just putting this question. Why is it hard? I want people to answer this one as they're writing this. Why is it hard to work with high-heeled shoes? Mud. On a soft ground, not in mud. On a soft ground.
raise the thing. Raise the hand.
So why? Who can answer this? And now, after answering this, we're all going to say look up on the shoes. Who can answer that question? That is the shoe, the kakondo. Maybe it has some stripes on it.
I'm trying.
The shoe sinks in the soft
Who
ground.
can answer? Who can try? Somebody can try. I see Chisache. Can you try? Chisache, try. Answer Chisache's hand.
Teacher.
Yes.
Because the less the area, the more pressure it exerts. Because the heel of the shoe is
the heel of the shoe.
Hello?
Hello, we are hearing you. Your brother is disturbing you.
Yes?
Yes, continue.
So because the hill is pointed, the area, I mean the first exercise on the ground is mud. So the less the air, because of the heel of the shoe is
Yes. The heel of the shoe has a small area, therefore.
Since the shoe is highly pointed, it exerts more force to the ground.
Therefore, there will be more force exerted.
And teacher? Teacher?
You didn't finish your answer because the heel has a sharp area, a small area, therefore
it exerts more force to the ground.
Discuss that answer. Tell your answer to them, they also tell you theirs. Okay, Victoria, what's your answer for this question?
Teacher, the sharp pointed part of the exerts more pressure to the ground since it has a small area.
Yeah, because it has a small area, it exerts more pressure. Now, in the process of exerting more pressure, it means your shoe at all times as you are walking, it will be entering into the ground. It enters into the ground deep because it's a sharp end, therefore it has more pressure. But this part, yeah, but what about this part? This part has large area. So you always see your kakondo entering into
The sand.
the ground. Your kakondo will be entering into the ground if this one is on the surface. So it becomes. Have you ever seen tractors? Why are tractors? Why do they have tires of large area? Tractors.
To reduce on the pressure they put on the ground.
To reduce on the pressure of force.
Why do tractors have large area? Tires of large area is to have less pressure exerted on the ground. And these tractors work in muddy places, in farms. When the farm is muddy, it's wet. If the tractor had a very small area, a tire of small area, what would be the problem? If the tractor is working in a farm and it has rained, and the tractor has a small
Get stuck.
Friction.
the tire would easily sink. It would easily sink into the mud, therefore making the work very hard, making the movement of the tractor so hard. That's why they make those tractors as of large area. When the tires are of large area,
Whose radio is on?
it must be.
Whose radio is that?
It is the Hannah's radio. She has muted. Okay, did you get my question? Why the tractors are made of tires with large area?
It wasn't me.
We said tractors, and the whole thing goes back to the pressure and area. When the area is large, when Shaharu mute. When the area is large, then the pressure is small. We have just seen this high heel shoe. When this area is small, then pressure will be high. So you'll be entering into the soft ground easily. Your shoe easily enters into the soft ground, so it makes your walking so difficult. When you come to the tires of the tractor,
You're frozen.
You guys, why is teacher stuck?
Yes, teacher, you're stuck.
Stuck? I don't want to answer things in the book. At him by now.
Guys, where is teacher?
Teacher disappeared. Excuse me, teacher, how are you?
I think yes.